Okay, everyone, let's resume. We might have to end slightly late. Just, just 5-10 minutes. आप भी तो लेट आए हैं वापस. ओके, अब नहीं जा सकते, लेट हो गए, रास्ते बंद हो गए होंगे अब. Okay, let's start with our next topic, which is circles. Okay, some basic concepts that you need to know of: how to find the circumference of a circle, 2 pi r, area of a circle, pi r square, diameter is two times the radius, right? Now, this is important. What's arc length? Let's say you have a sector like this, sector OAB, where O is the center. What's the arc length of this sector? AB, right? This is called the arc length, the length of this arc. There's another terminology that you will see being used. That's called arc measure. That's not the same thing as arc length. Arc length is going to be in the unit that you have for distance, generally meter, centimeter, feet, right? Something like this. Arc measure is an angle. Arc measure is the angle that the arc has at the center, the arc makes at the center. So if the angle at the center is 80 degrees like this, you say the arc measure of AB, the measure of the arc AB is 80 degrees. Is that okay? That's a terminology that is used on SAT sometimes. You need to know it's different from arc length. Okay? Now, minor arc is the arc that has an angle less than 180. Major arc is the arc that has an angle greater than 180. Generally, when they refer to major arcs, they will be referring to this point that on the other side like this as well. So for major arc, they would write APB instead of just writing AB, just to make it clear that they're talking about the major arc. So they include the letter P in there as well. Okay. Now, what's the arc length formula? All of you have done this. The arc length of a complete circle is 2 pi r. Circumference is 2 pi r, right, for a complete circle. If you want arc length for a part of a circle, you just find the ratio. For example, if this angle is theta, angle of the whole circle is 360. You say theta over 360 into 2 pi r. It's done using proportion, basically. The complete arc length is 2 pi r. If you want arc length for a specific sector, that's just theta over 360 into 2 pi r. All right? Now, let's say you've got this circle, and you're given that AB, so let's say this is not given. Yeah. So you're given that arc AB constitutes 1/6 of the circumference. It's 1/6 of the circumference. What's the arc length if the radius is 9 units? So we need to find arc length. What's the arc length formula? Theta over 360 into 2 pi r. What's theta? We don't know that. It says it's 1/6 of the circumference. What does that mean? If the complete angle is 360, what's the angle going to be here? 60. So this angle is going to be 60 degrees. So you say it's 60 over 360 into 2 pi into 9, and that's going to give you the result. Is that okay? Make sense? Sorry? Because it says arc AB constitutes 1/6 of the circumference. For the whole circumference, the angle would be 360, right? That's a complete circle. So using ratios, what should this be? 1/6 of 360 is 60 degrees. Is that okay? All right. What's the area of a sector? Area of a sector, theta over 360 into pi r squared. Area of a whole circle is pi r squared. Just find the ratio of that theta over 360 into pi r squared. You can find area of sector like that. Now, this is another important terminology that you need to know of. It's called inscribed angles. Inscribed angle. An inscribed angle is an angle whose vertex lies on the circle and the legs are on the chords of the circle. Now, what does that mean? It's basically very similar to, or the same as, that property of circle that you did in O-levels. Angle at center is twice the angle at the circumference. Now, they're saying this arc's measure is 100 degrees. What does that mean? The angle that this arc makes at the center is 100 degrees. So that's why this is the measure of that arc. And then using that property, angle at center is 2 times the angle of the circumference. We know that if this is 50, this is going to be 100. And if this is 100, the arc measure is 100 here. Is that okay? No problems? Now, some properties of angle properties of circle that you need to know of, the same properties that you've done in O-levels. Let's quickly go through them as well. Angle made by diameter is 90. So if you have a diameter and that angle makes an angle at the circumference, that's always 90, right? And only diameter can make an angle of 90. No other chord can make an angle of 90, okay? Tangent is perpendicular to radius, right? If you have a tangent at a point and you also have radius at that point, they're always perpendicular to each other. Now, this is very important. This property that if you have a chord and a line comes from the center of the circle to the midpoint of the chord, let's call this point M. If there's a line that's coming from the center of the circle to the midpoint of a chord, the angle that it makes here is always 90 degrees. Its opposite is also true. If you know that the angle is 90 degrees, that means the chord is going to be bisected. It's going to be cut into 2 equal parts. Is that okay? No problem? If the chord is cut into 2 parts, the angle is 90. If the angle is 90, the chord is cut into 2 parts. So if you know any one of the two, you can infer the other. Okay? Tangents coming from an external point, another very important property. If you have a point outside a circle from which you're making 2 tangents, one on one side of the circle, one on the other side of the circle, they're always equal to each other. These 2 lengths are always equal to each other. Now, if you extend this and make a shape like this, tangent and radius are always perpendicular. This is 90, this is 90. These angles are 90. Let's call this center O. Let's call this point A, this point B. OAXB, this quadrilateral that you see here, this is always a kite. This quadrilateral is a kite. Okay? What's a kite? Its adjacent sides are equal, right? So you see this is radius. These 2 sides are equal, adjacent sides are equal. That means it's a kite. If you break a kite into 2 parts like this from the middle, you get 2 congruent triangles. The above triangle and the below triangle, they're both congruent. This angle and this angle, they are the same. This angle and this angle, they're also the same. The angles are bisected if we draw a diagonal like that. So, is that okay? So you should understand all of these properties. And there's another property of kite. If we draw another diagonal like this, these diagonals are always perpendicular. Kite ke jo diagonals hote hain, they're always perpendicular to each other. So from this one property, tangents coming from outside a circle, you get all of these things. You need to understand all of them. No problems? Okay. Let's do some examples now. The circle shown has center O and points A, B, and C lie on the circle. Angle AOB is a right angle. What's the measure in degrees of angle ACB? 45. Angle at center is twice the angle at circumference. If this is 90, angle at circumference is going to be 45. We say this is 45. Make sense? Okay. A circle has radius of length 9 inches. The length of arc AB on the circle is 4 pi inches. What's the measure in degrees of arc AB? Radius is given, arc length is given, and you need to find angle. You can use the arc length formula. What's the arc length formula? Theta over 360. Angle is what you need to find out, right? Measure. Measure of an arc measure. What's that? The angle that it makes at the center. So we're looking for the angle, right? We discussed this in the beginning. Arc measure means the angle that the arc makes at the center. So we're looking for theta. Theta over 360 into 2 pi into r, which is 9. That should equal 4 pi. You can find the value of theta from this. Is that okay? हो जाएगा ये? No problems? Okay, let's have a look at this now. In the circle shown, point O is the center and the diameter AC has a length of 10 inches. The measure of arc AB is 60 degrees. What does that mean? Measure of this arc. Which angle are we talking about? No. If we make this angle, this is going to be 60 degrees. This is the arc measure. Okay? Now, what's the length of BC? How do you figure that out? What else are we given? AC is 10. That means the radius is 5. This is 5. This is 5. And that's all the information that we have. What's the length BC now? One idea is we say this angle is 120 and then use cosine rule. Or we could make it slightly simpler. It's an isosceles triangle. We can break the isosceles triangle into two parts. Make a right angle here like this. So you have this right angle triangle. Let's call this point X. This whole angle was 120. So this is 60. Can you find the length of XC now? Which ratio do we use? 5 is hypotenuse. XC is opposite. Opposite of hypotenuse is sine. Sine 60 equals XC over 5. Or this is a special triangle. Remember that? 30, 60, 90. You could do it without trigonometry as well. The hypotenuse is 5. The smallest side is going to be 2.5. And this side is going to be 2.5 under root 3. Make sense? And then this complete side BC is going to be 5 under root 3. And that's what we were looking for. Or we could make it much quicker. Could we? If we look at that complete angle, that's a 90 degrees. That's 30. We know one length. That's the hypotenuse. Okay, so we could actually make it much quicker than this. This is one way of thinking about this. Another way to think about this could be, we know that this angle is 60, right? If this is 60, what about this angle? 30. Angle at center is twice the angle of circumference. You make this triangle. This is a right angle triangle as well. Angle made by a diameter, angle in a semicircle. This is 90. This complete length is 10. And again, you have a 30, 60, 90 triangle. You can use trigonometry if you want, or if you remember those ratios. If this is 10, this is half of that, which is 5, and this is 5 under root 3, and D is your answer. Is that okay? Equation of a circle. Now, those of you who haven't done this in A-levels, this is also another concept that you need to know about. Equation of a line is given by y equals mx plus c, or y minus y1 equals m into x minus x1. You also need to know equations of a circle, equation of a circle. This is the standard form of the equation of a circle. You will need to remember this. X minus h whole squared plus y minus b whole squared equals r squared. Just like we have y equals mx plus c, y minus y1 equals m into x minus x1. For circles, we have this. Okay? This is the standard form for equation of a circle. Now, for a line, we needed two things: gradient and a point. For a circle, we also need two things, and those two things are the radius of the circle and the center of the circle. These are the two things that we need to write down the equation of a circle. For instance, if we know that a circle has a center minus x5 and radius is 8, hk in this form are the coordinates of the center, r is the radius. What is the equation of the circle going to be? Just input values here. You say this is h, this is k, and this is r. So the equation becomes x minus minus 6, which is x plus 6, whole squared, plus y minus 5 whole squared equals 8 squared, which is 64. That's the equation of the circle. Is that okay? You need to memorize this form. X minus h whole squared plus y minus b whole squared equals r squared. A and b, or h and k, x minus h whole squared plus y minus k whole squared. Sometimes you write a in place of h or b in place of k as well. It doesn't matter, you can use any letters. These are the coordinates of the center, and this is the radius. Okay? Now, what does this equation represent? It represents every point on the circumference of a circle. So if you have a circle like this, it represents points on the circumference of the circle. So every point on the circumference, if this is the equation of the circle, every point on the circumference will satisfy this equation. It does not represent points inside the circle or outside the circle. It only represents points on the circumference. Is that okay? Any problem with this? No? You need to remember this now. Let's have a look at this. The equation x squared plus y squared equals 9 represents a circle in the xy plane. A new circle is drawn whose center is 8 units down from the center of the circle and whose radius is 7 units longer than the radius of the circle. Which of the following is an equation of this new circle? Now, how do we think about this? Write down the standard form. X minus h whole squared plus y minus k whole squared equals r squared. That's the standard form. What's the center of the circle? What's the center of the circle? Yes? Is it in this form? We could think of it as x minus 0 whole squared plus y minus 0 whole squared equals 3 squared. Right? So the center of the circle is 0, 0. That's the origin. Radius is 3. Make sense? Now there's another circle. Its center is 8 units down from the center. 8 units down. What does that mean? What's the center? What's the new center? Anyone? What's the center of this new circle? 0 minus 8. Radius is 7 units longer than the radius of the first circle. The first circle had a radius of 3. What's the radius of this circle? 3 plus 7, that's 10. What's the equation going to be? X minus 0 whole squared plus y minus 8. That's y plus 8 whole squared equals 10 squared. So that's x squared plus y plus 8 whole squared equals 100, which is D. Is that okay? Any problems? First, a circle का radius 3 था. इसका radius 7 units ज़्यादा है. So 3 plus 7, that's 10. Okay. All right. A circle in the xy plane has center 5, 6 and intersects the x-axis at exactly one point. Which of the following equations represents the circle? Center is at 5 and 6. So x minus 5 and y minus 6. B and D are not possible, right? Because we want x minus 5 and y minus 5. Y minus 6, sorry. Right? उसमें दोनों में plus आ रहे हैं. They're not possible. So it's either this or this. What do you think? It touches the x-axis at only one point. Think about it. You have a circle. Where is the center of the circle? 5, 6. Center is at 5, 6. And there is x-axis here. X-axis looks like this. Equation ही नहीं पता तो x-intercept कैसे निकालें? This is the situation. We have the center and it just touches the x-axis. Do we know the radius of the circle? 6. Because this length is going to be 6 units. X-axis is y equal to 0 line. Here the y coordinate is 6. So from 0 to 6, the radius becomes 6. So that means on the right side, we need 6 squared, which is 36. It should be this. Is that okay? No problems? A circle in the xy plane has a diameter with endpoints -5, -2, and 9, -2. Which of the following equations represents the circle? What do we need for writing down the equation of a circle? You need two things, center and radius. Can we find the radius? Find the distance between these 2 points and half that number, right? Midpoint will be the center of the circle. What's the midpoint? 2 minus 2, right? That's the midpoint. And if you notice, the y coordinates are both the same. That means distance is just -5 to 9, which is 14. So radius is 14 over 2, which is 7. You can just subtract these two numbers because y coordinates are the same. So the distance is going to turn out to be 14. Radius is 14 over 2, which is 7. Center is midpoint of these two numbers, which is 2 minus 2. So the equation is going to be x minus 2 whole squared plus y minus 2, which is y plus 2 whole squared equals r squared, that's 7 squared. Which one is that? A. Is that okay? Right? Any problems? Okay. Yeah, we're almost done. What if we have to find the center of this circle and radius of this circle? This is not in the standard form, right? X minus h whole squared plus y minus k whole squared equals r squared. We can only find the center and radius if it is in this form. If we want the center and the radius, one idea is that we convert this to the standard form like that. For that, we would have to complete the square. Remember completing square process? What you do is you complete the square for x terms separately and y terms separately. Keep the constant on the other side. 6 divided by 2 is 3. Add 3 squared and subtract 3 squared. Similarly here, add 2 squared and subtract 2 squared. These three terms give you a perfect square. So that's y plus 3 whole squared minus 9 from here plus y minus 2 whole squared minus 4 from here equals 5, and that gives you x plus 3 whole squared plus y minus 2 whole squared equals 5 plus 4 plus 9, and this is 18. Okay, so what's the center then? Compare it with the standard form. This is plus 3, you just flip the sign. This is minus 3 and 2. That's the center. Radius is square root of 18. So for finding the center and radius from that form, you have to complete the square first and then find the radius and the center by comparing it with the standard form. Compare it with this form. Minus h is equal to plus 3. So h equals minus 3. Similarly, minus k is equal to minus 2. So k is equal to plus 2. You will always flip these signs for finding the center's coordinates, because when you compare with that form, वहाँ पे minus h or minus k, so you flip the signs. Is that okay? You have this equation given. You have equation of a circle given. You have to find the length of the circle's radius. Now, one idea is that you complete the square and then compare it with the standard form. It's not going to be very straightforward. It's going to take time. In the earlier example, we had x square only, and the coefficient was x square and y square. They were both 1. Now they're not 1. We have 9 here. We'll have to take 9 common outside or divide the whole equation by 9 and then go further with this. You can actually do this without completing the square as well. Any guesses? Desmos. We could just sketch this on Desmos. Put this whole thing on Desmos. Without completing the square, you can write down the radius directly. Let's do that. So this is Desmos. Just put that equation directly here and see what that gives you. 9x squared plus 9y squared plus 9y squared plus 18x minus 36y equal to 4. And you get the circle. Okay. What's the radius of the circle now? You can see what the center is. Center is at minus 1, 2. What's the lowest point on the circle? Minus 1 over 3. minus 0.333, right? That's minus 1 over 3. Can you find the radius now? 2 plus 1 over 3. That will be the radius. Or you could do it sideways as well. You can do it anyway, right? This is an alternative you have to completing the square. If you don't want to complete the square, just graph this on Desmos and find the radius directly. Center पता चल गया? This is the center, minus 1 and 2. इससे right चले जाए, left चले जाए, wherever you want to go. Let's say we go right, horizontally. What's this point? आप इस पर click करेंगे Desmos पे, you'll get 1.333 for this. Okay? So you just find the difference. Minus 1 to 1.333. The radius is 2.333 or 7 over 3. Okay, 2.333. You can just write that down. The alternative was completing the square and then doing it, but that will be too long. Desmos is very helpful in such cases. All right. Okay, I'm sorry for taking 7 minutes extra. I'll end this here. I'll see you again on Monday, inshallah. Allah Hafiz.